Alrighty, polygons. ABC are polygons. D, E, F are not polygons. So things you might notice D, E, F don't have. Or have. Curves, open parts, crosses. So you can't have curves, no gaps, no overlaps. A convex polygon has, I'm going to say it this way, all the corners point out. What I mean when I say that is you have a shape like this. All the corners are like farther out than the sides. A concave polygon has at least one corner that points in. And what that would look like would be, so this right here, both of those angle or corners point in, if you know what I mean, into the middle of the shape. And so that makes it concave. So they make little caves. So if you look back at the polygons at the top, polygon A is concave, and polygons B and C are convex. So even though this corner like is farther inside than the one next to it, it still is outside versus kind of going in. All right, you should know the names of the polygons. Three-sided. Four-sided, we're going to use the word quadrilateral because there's a whole bunch of four-sided shapes, and we're going to talk about squares and rectangles and rhombus and parallelograms and all that stuff. So all those are classified as quadrilaterals. Then we have pentagon, hexagon, heptagon, octagon, nonagon, decagon, and 12 is a dodecagon. All right, and after you get to 12, usually you just use the number and a gon. So we would say 15 gon, you would know is a 15-sided shape polygon. Okay, naming polygons. You can start with any letter and work your way around the polygon. So you have to at least go in order, because if someone saw the name, they should be able to redraw the exact polygon you're talking about. So we could do U, V, W, S, T. Or we could go the other way, it doesn't matter. We could do T, S, W, V, U. So it doesn't matter what you start with, and it doesn't matter which way you go around the polygon as long as you put the letters in order that they come consecutively around the polygon. All right, a regular polygon is the one you're used to seeing. It has equal sides and equal angles. Okay, so that means if it doesn't have equal sides, it's not regular. It's still a polygon, but it's not regular. So a regular triangle has all the sides and all the angles the same. There's only one triangle that does that, and we call it equilateral. And a regular quadrilateral, all the sides have to be the same and all the angles have to be the same. And the one that matches that criteria is a square. Okay, here's the way we're going to look at the patterns for finding the degrees of the angles inside a polygon. So we're going to basically look at triangles, because what we know about triangles is they have 3 sides and they have 3 angles. It makes one triangle, and there's 180 degrees in a triangle. And we've proved that and looked at it and done all that. Okay, so for the rest of our shapes, we're going to make triangles. We're going to pick a corner of the quadrilateral, and we're basically going to draw lines from that one point to all the other corners, vertices. Okay, if you look at a quadrilateral, you have 2 triangles. So a quadrilateral has 4 sides, 4 angles, and it makes 2 triangles. And if each triangle is 180 degrees, then a quadrilateral, the angle should add up to 360, which we know if we think about a square or a rectangle, we have 4 90-degree angles. And so 4 times 90 would be 360. So let's do the same thing with our pentagon. There's 5 sides and 5 angles. So I'm going to pick this point right here. And those 2 sides don't really count. So I have 3 triangles. And so all the angles in the pentagon added up are going to be 3 times 180, which is 540. Yeah, 540. Okay. So you should start seeing a pattern. Hexagon has 6 and 6. Guess how many triangles we can make? I hope you said 4. So we have 4 times 180. Oops. 720. No. Yes. Okay. We use the letter N for the number of sides. So when we say n-gon, we're talking about a polygon with n number of sides. We don't know how many sides. But if I was going to write it out, I would say that it has n sides and n angles. So if it was a 22-gon, it would have 22 sides and 22 angles. So if you look at this and think about how we ended up with the number of triangles, hopefully you notice that it's 2 less every time. So if I wanted to know how many triangles there were in my 30-gon, it'd have 30 sides, 30 angles, and 28, 30 minus 2, 28 triangles. And so I would multiply n minus 2 times 180. So if we're looking to add all the angles in a polygon, we would use the formula. And if I want one angle of all the angle measurements we just did, I'm going to take what we just did, the total number of angles, and I'm going to divide by how many angles there are. And that should give me 1 angle. So let's see how we would use this. So we're going to find the sum and 1. So we're talking about a nonagon. Nonagon n equals 9. So to find the sum, we're going to do 9 minus 2 times 180. And you don't really need to write this because you could pretty much just write 7 times 180. All right, and 7 times 180 is 7, 8, 9, 10, 11, 12, 1, 20, 12, 60. That would be all the angles on a nonagon. So notice, once the bigger it gets, the more sides we have, the bigger the polygon gets sidewise. the bigger the angles get. So for 1, I'm going to take 1260 and I'm going to divide by 9. And I'm going to get 140. So each angle in an octagon, if it's regular and all the angles are the same, would be 140. And 140 times 9 is 1260. All right, so let's try the same thing with a decagon. So now n equals 10. So the sum is going to be 10 minus 2 times 180, which is 8 times 180. So it's going to be 8, 1, 4, 1440, I think is what that is. Okay, so that would be all of them. 1 would be 1440 divided by 10, which would be 144. So each angle would be 144 degrees. Okay, so number 3, not regular. But n is still 6. The sum is still 6 minus 2 times 180. And we did this up at the top, which is 720, right? Okay, so I'm going to add up all the angles I have, subtract from 720, and that's going to be my missing angle. So I'll change colors. So I'm going to do 106, 147, 125, 143, and 98. 10, 29, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 1, 2, 3, 4, 5, 6. Okay, so 619. So I'm going to subtract 619. And I'm going to get 101. So this angle right here is 101. So even if it's not regular, the angles are still going to add up to the same thing. Just that the angles are not all going to be the same. So I couldn't divide by how many sides or angles there were.